Welcome back to the workshop. It's good to see you again. It's cold in here today. It's only October, but 10 degrees apparently in here, so hence the scarf. This is the follow-up video for building this workshop. It's been stood up here now for over a year or so, and it's been my most popular video. In fact, I've got it up on a screen here. It's had 292,776 views. Blimey. Thank you one and all for that. And 548 comments. And that's what's prompted this video. Excuse me, I'm getting over COVID. Who'd have thought COVID was still a thing? This video is a direct response to the comments I get on building this workshop. And it basically falls into two categories. Did I need planning permission? And did I need to follow building regulations? And the answer is yes. So let's get the titles over and I'll explain exactly what you do and don't need to do in order to build something like this yourself. So here are the weasel words. In the UK, you're allowed to build certain structures in your garden, like garden workshops, sheds, garden annexes, summer houses, etc., greenhouses, garden offices, etc. And you can do what you like as long as you abide by the rules. And the first of which is that as long as it's less than 15 square metres floor area, you can do more or less anything, as long as you abide by the rest of the rules. If you however go to up to 30 square metres, you can indeed get that without having to use building control, which means you can build up to the size of a double garage, I believe. However, you have to abide by the rest of the rules. So your shed, workshop, summer house, office, whatever, cannot be in front of the principal elevation for the property. In other words, it can't be in your front garden overlooking the road. So it has to be to the side of the building or behind the building so that it's not visible from the road. It has to be single story. You can go eaves up to 2.5 metres high, which is quite substantial, and a 4 metres maximum height. However, you have to be 2 metres away from the edge of your property to do that. If you're within 2 metres of a boundary, or curtilage as they call it, then you're limited to a maximum height of 2.5 metres, and the eaves have to be, I think, 1.25, 1.75, something like that. So that limits, if you want to put your shed up against the edge of your property, let's face it, most of us do, then you're limited in your height and scope. You can't put a deck or a veranda in that's more than 300 mil, that's 12 inches, and you cannot go beyond, size-wise, you cannot go beyond half of the original area of the building, which is a really odd thing to say, but I think back in 48, something like that, there's a rule that says this is the size of the property that was built at that time, and your shed, workshop, summer house, whatever, can't be more than half of that original size of the building. Not really a major problem, I don't think, but it's there. And finally, if you're on listed ground or your property's listed, you've got to apply for building control and planning permission. So in order to answer your question, yes, I did need building control. Yes, I did need planning permission. And the square footage of this, or square meterage of this, is 45 metres inside. So I'm well outside of the 30 metres maximum, which meant I needed planning permission. Now, let's move on to planning permission. So we've arrived at a planning application. As you've seen, I needed a planning application for here. So that's where it starts to get a bit more complicated. The planners are not interested in how you build it. They're interested in where it is, whether or not it can be seen from the road. Is it too big? Is it close to the neighbour's garden? Are the neighbours likely to object? What size the overall thing is, how tall it's going to be, what the material you intend to build it from looks like. So they're far more interested in the aesthetic appeal of the new building. So you have to put together a pack. So you have to put together, you need an ordnance survey plan, and on that plan you have to draw what you're going to, what you intend to build, as obviously just a standard plan, rectangle in the case of this thing. You also have to say clearly where you are, so they need the grid references, and that all comes with the OS plan anyway, the OS map. An artist's impression is always a good thing to show exactly what the thing is going to look like once you've finished it, and how it settles in the landscape you intend to build it in. So they're really into the aesthetics. What's it going to look like? Is it going to be objectionable to people? Are you going to intend to run a business in it? Because if you do, then you're in a whole new level of issues. But a hobby space, which is what this is, actually becomes a little bit easier in that respect. So you put together your plan, your pack, and you send it off to the you apply for your planning application, and then you do nothing basically for another 8 weeks, because that's how long it takes them to get round and give you a decision. In the case of this one, there was an objection, and the person who objected, quite rightly I feel, felt that we were going to run a business out of here. They were not aware of the fact that I've retired, or was in the process of retiring, and I didn't need the income, so I wasn't going to ever do anything in here that's commercial. In fact, making YouTube videos is all I really wanted to do, because I find it quite fun. So the planner, very nice lady, rang me up and she said, I need to discuss what you want to do with your new workshop. Should I give you planning? And I said, basically, I'm retired. I'm a model engineer. I make stuff. I just enjoy working stuff through in my workshop, and I don't intend to do anything commercial at all. In fact, I'm not going to do anything commercial. The days of feeding CNC machinery with pieces of wood, etc., is just no. I don't need to do that anymore. I'm not doing that. So she said, "Okay, I'll give you planning." And the kicker was, and I didn't know at the time because I didn't really fully understand the permitted development. She said, because you're over 30 square metres with what you want to do, I'll pass your details over to building control. And at that point, my heart sank. So that leads us on to the next step, building control. So we've arrived at building control. So let's have a little précis. You can do stuff under permitted development. That's absolutely hunky-dory, but it's got to be within certain size constraints, and it has to be within a certain position within your property. No problem with that. That's going to work for most people. Next is planning. So as we've seen, the planning is more akin to the aesthetic look of the place. What's it going to look like? How big is it going to be? Where's it going to go? Are there going to be any objections, etc., and that sort of thing. And then that leaves us with the third and the most complicated by a considerable margin, building control, or building regulations, if you like. And the people there don't give a monkeys what you make it from. You can make it from cheese, as long as it's structural cheese. Don't use biscuits, but cheese, absolutely fine, as long as it can bear the load. So they're more interested in how's it going to perform as a building? Is it going to be strong enough? Is it going to be suitable for the environment that it lives in? And that's a slightly odd statement, but so let's just go through a few bits and pieces. So I'm going to start at the top with the roof. The roof I chose is a tin roof and corrugated tin, and the reason that I chose that is it's a cost benefit ratio. It was the cheapest, most durable roof I could find, and here's the rub. I'm 60, and I'm trying to do stuff that I won't have to do again. So I spoke to the manufacturers of this roof structure, and they assured me that it would last 25 to 30 years. So that puts me 85 to 90. So am I going to be out here doing much in the way of model engineering or building stuff when I'm 85 to 90? I'd like to think I could, but realistically we both know that I'm going to be watching daytime TV. If TV still exists, but that's another story. So I'm doing stuff now that I don't have to repeat again, hopefully, in the rest of my time on the planet. So hence why I went with that particular type of roof. Also, it's a lightweight roof, so it doesn't need quite so much structure to support it. So you ask yourself, okay, how do you design your roof? Well, I'll put a link into the spreadsheet that I used down in the doobly-doo, as I will all of the spreadsheets, etc., that I used. And it's a paid-for product, but it allows you to put in the weight of the roof you're going to be using. Once you can calculate that, you know how much weight is per square metre on the tin. That's readily available. You can then work out how big the roof trusses need to be, how far apart they need to be, and how big the purlins need to be underneath to support it, to triangulate it. So you just plug all that data into your spreadsheet, and it'll come up with some numbers, and it will come up with some sizes of timber that you're best to use, and you can fiddle around with it and talk to your local building supply company, and you'll get a sense as to how you can make it out of thinner pieces of wood, but you need a lot more of them, or obviously chunkier pieces of wood and you need fewer of them, but they get heavier to lift, etc., etc. So you'll come up with your design for your roof, and you'll come up with the calculations, more importantly, to prove that what you're going to do is going to cope with the load. And the load also has to be able to put up with a snow load. Now, I know we don't get much in the way of snow these days, but we could do. And as a result, the roof has to cope with the fact that there might be 2 feet of snow on it, which adds considerably to the load. Anyway, so we've done that. We've got our roof rafters and purlins designed. That's good. The next thing is we need to look at the amount of rain that's going to fall on that roof. So if you look at the Met Office data for where you live, they will tell you what your average rainfall is. Here, for instance, we get about 600 millimetres of rain a year. And, yeah, okay, that's good. It's quite a dry part of the world. I mean, East Anglia and Norfolk in particular, very dry part of the world. Your drainage system has to be able to cope with a certain amount of an overload, and that means that you need to know how big the square meterage, of your roof, multiply that by the maximum amount of rain that's likely to fall on it, and that will give you a volume. That volume is what you then need to calculate the size of your soakaway. And your soakaway also has to be, there's a datum level, if you like, with these sort of structures, and the datum for me is floor level. So, excuse me, the ground outside is 150 mil below the floor level in here, and that's a standard figure that you'll all have to abide by. That means that the drains have to be no more, the top of the drain has to be 150 mil below the level of the floor. So that then dictates how deep you have to dig the hole for your soakaway. And my soakaway, I think, ended up being about 2.4 metres deep. That's 8 feet. So that's quite a hole. And also, your soakaway has to be at least 5 metres away from any building. So it's 5 metres between the house and this workshop is 12 metres. So the soakaway is actually between the two, and there's just enough space to get it in there. If my neighbour had either of my neighbours had a building right up against the fence, then I think I'd have to be 5 metres away from that as well. So sighting of where you put your soakaway is quite important. I got it wrong to start with, and I had to fill the hole in and start from scratch because I misread the rules, and I was 2.5 metres away, not 5 metres away. So I sorted that absolutely fine. So we've done the roof. We know what the drainage is going to be. We know how big the soakaway is going to be. We now know where you can work out where the soakaway's got to go. That leaves us to the walls. The walls have to be able to cope with the weight of the roof, plus the snow load, plus the windage. And again, you need to go to the Met Office website, and it will tell you what your average wind speed is, and that then you have to apply some correction factors to it, because here I'm 30 odd miles away from the sea, so there's 30 miles of land between the open sea and the open wind and this building. So that reduces the effect of the wind. Also, we are pretty much at sea level here in Norfolk. There's very little more than like 150 feet above sea level. We're really quite low. So that doesn't affect it. But if you want to build your shed on the top of a mountain in Cumbria, then the wind is going to be significant. And the wind is significant because of a thing called racking. If you can imagine a standard studwork wall, lots of verticals, wooden verticals, a beam across the bottom and a beam across the top, that sort of ladder structure, if you apply a wind load to one end of it, it'll want to rack. That's the description of it. It'll just try and push it over. So your shed, workshop, summer house, whatever, garage, whatever it is you're building, has to be able to cope with that wind load. So the next spreadsheet will help us design the walls. We know what the load is going to be on the top of the wall. We know that the bottom of the wall is going to be supported by the concrete slab, so that's not going anywhere. We know what the wind speed is going to be. So basically, you can plug all that data into this next spreadsheet, and you'll come up with the size of timbers and the distance between them to build your walls. Excuse me. Here's my rule of thumb, and I think this applies to everybody. Make them 600 mil or 400 mil. And that is because the width of a plasterboard sheet is 1.2 metres, so if you have them at 600 mil, 3 verticals will do 1 sheet. Or if you have them at 400 mil, 4 verticals will do 1 sheet. That then makes it far easier for you to do your planning, and the fact that your verticals will always be at the edge of a plasterboard sheet. Perfect. So that will give you the size of the timbers. In that spreadsheet, you can also pick out what you're going to sheathe the inside and outside with, because that will make a difference to the resistance to racking. So plasterboard, for instance, is a lot easier to push over than plywood. So this particular shed has got OSB oriented strand board on the outside and plasterboard on the inside. and that proved to be strong enough to do the job. So we've got as far as the walls. The most complicated bit by a long shot was the concrete slab, and I could find very, very little in terms of the slab as to how thick it needs to be, what kind of load it's expected to put up with, etc. And in the end, I found an Indian spreadsheet for the Indian equivalent of building regs here in the UK that gave me some sort of insight. And unfortunately, it would not, the spreadsheet would not deal with the size of slab I've got here. So I broke it into 4. So I split it halfway and halfway. So effectively, I could do the calculations on 1/4 of the slab, and that proved to be okay. And the building control were quite happy with what I'd done. It's way stronger than it needs to be, and there's a reason for that, because I've got machinery that's bolted to it, and some of these CNC machines are or lathes, etc., are only as accurate as the bit of concrete they're screwed to. So you can take some of the twist and warp out of the beds on these machines by jacking them down carefully to the concrete slab. This slab has got about 18 tons of concrete in it. It was the only piece of the whole construction I couldn't do myself. So I had to get a team of lads in and a concrete pump to pump it over the house into the hole. It's a minimum of 6 inches, 150 mil thick, and a maximum of 450 thick. So the outside is running at 450. Then I think it goes to like 400 or so through the beams in the middle, and then 150 mil for the rest of it. So there's a lot of concrete in here. And again, you have to provide some form of calculations. If you intend to use steel to reinforce your slab, then you'll have to look that up, and you can find the calculations for how much steel you need to put in, given the expected load on the floor, on the slab, I should say. I decided that I didn't want to use steel if I could help it, because it's more expensive, and also it just struck me as being quite an old-fashioned way of doing it. So this floor has got fibre in it. It's a plastic fibre that's like thick hair, if you like, that's mixed into the concrete batch, poured in the hole. You can't see any of it, but it doesn't crack. What it does is it binds that sort of random lattice of plastic pieces, binds the cement together into a consolidated lump. So it won't crack. That's good news for the machinery that you bolt to it. Also, it makes it, I think, a little bit more durable. And on top of that, we have an epoxy membrane, a damp-proof membrane, which is epoxy bitumen, if I remember rightly. And then on top of that, there's another epoxy floor paint, which is the grey that you see on the finished floor. And so that's it. Once you've calculated all of those things, you have to send the calculations for the roof, the walls, the drainage, the windage, and the slab off to building control, and they'll think about it. And if they've got any questions, they'll come back to you. If they don't, then you're good to go. You will need to pay the fee, and you will also get access to a building inspector at that point. So, and I would absolutely recommend that you get to know your building inspector, because they are full of really useful information. And don't be antagonistic with them. They're only doing the job, and they're there to make sure that you build something that's suitable and sufficient. That's something you get a lot in health and safety legislation, suitable and sufficient. So what you don't want is to spend all this money on your new shed, workshop, garage, summer house, whatever, only for the next big storm to come through and ruin it. So it's important to get it right. So there we go. That is building regs in a nutshell. Apologies for that. So having gone through all of the drawings, such as they are, that you need to submit to planning and building in order to get yourself to the point where you can start construction, this building has been up for well over a year now, so let's go and have a wander around and we'll have a look and see what has worked and what needs attention and what I would change if I did it again. Firstly, over here at the door, the pawl on the door latch has completely and utterly mullered that door jamb there and there. Everywhere else is fine and dandy. It's faring well, but that piece there really does need a little bit of attention. Both sets of windows are faring up really quite nicely. None of the paint, they're filthy, but none of the paint has flaked off or chipped off, which is good, because they were white, and this is just a particular paint that you can use on windows to change the colour. However, I just grabbed these two pieces. I've yet to do these. These are the weep vents. These windows were actually designed to be mounted that way, vertically. So this edge comes out this way and would actually shed water flowing along that way. However, that meant I've used them in the wrong orientation, so that meant that the weep vents don't work. So I've 3D printed two replacement weep vents that that's the top half, and there's another one that does the bottom half. They're handed pairs. Hang on, let me put them together. There you go. Hopefully you can see what I mean. Yeah. However, I've needed to get my little CNC router up and running because these will just fill up with insects, so they need an aluminium plate over the top with lots of holes in it in order to allow the trickle ventilation to work without letting the insects in. All right, here's a shot clean through the weep bench. You can see, I don't know if you can see, but those slots go all the way through the whole window. So I do need to put the covers over the outside here. Here's the inside of the windows, where you can see that's the handle to open them, although like I said they're in the wrong orientation. And here are the inside trickle vents. They're not really necessary in a dwelling like this, I suspect, but they're all holding up really well. Really pleased with that, along with the bench. This bench is showing signs of wear, but it's not horrific. In fact, I'll go as far as to say it's holding up really quite nicely. Now, this is where I did have some problems up there, which is pretty difficult for you to see with the sky in the background. Have a look. Because the boards have a little gap between them, that little gap meant that wasps could get through and into the roof space, and the little bastards did. I had a real fight to get them out. I came out here when we noticed that there were wasps in the eaves, and I just stood here watching them and thinking, there's quite a few, I'm going to have to deal with those, and turned round and there must have been a dozen literally where the camera is, where you are now, all hovering, waiting to have a go at me. So I thought, it ceased to be something that you need to deal with and become a major problem. So I spent absolutely ages destroying the little buggers. The cladding across the whole building has held up really well. I mean, I'm really impressed with it. There's no sign of any rotting or any problems on the bottom edges anywhere around the whole thing. The colour is blending in lovely. You can see where all of the nails went in, and these are galvanised, so my guess is they are slowly rusting in. But that's not the end of the world, not fussed about that. It looks absolutely great. The roof is holding up brilliantly, and the exterior lights are working well. I'll just turn them on. Right, path lights, floodlight, rear lights, fence lights, turn them all on. There we go, there's the floodlight for the patio area. The patio's done really well. The slabs have settled slightly, and it's going to be really difficult for you to see this, but that one is probably 2 millimetres, 3 millimetres higher than that one, and that's replicated across the whole of the thing. So they've settled, but they've not got any worse. And I do love the fact that the moss has taken over. I think that looks absolutely cracking. It's sort of bedding in nicely. Yes, I know it's a piece of scrap steel, but I'll get rid of that eventually. Here we are with the side lights, or path lights. They're all working a treat. The panelling looks cracking. As I said, I'm really pleased with that. That's showing no real signs of any distress or problems. This is the other thing that's wrong with these doors. These trim panels have come adrift, and you can almost get your fingers in there. So that needs to be fixed. There you go. The two rear lights are on, and there's just enough light here to illuminate this area. This is yet to be done. There's a path to go in here, down as far as this drain, and there's work to be done here, steps up into what will be the replacement patio. Down the side you can see the path lights. They're all working a treat. I've got this scrap wood here for the time being. That's there to protect the corner, because the actual corner, that piece there, is an aluminium extrusion. Very easy to damage it. So I've left these on for the time being on both ends, and that's because I've yet to put in the path down the side here. And that leads me to, I think, probably my biggest regret. I didn't know at the time you don't put screws in this is called hardy plank. It's a fibre board that's fireproof, and I had to put it in here because we're so close to the fence. So I had to do this, and I put screws in to support it, and I should have just put hidden screws underneath so you can't see them. That's my bad. This is yet to be done. There's two of these, one either side with the two downpipes, and that will be for water harvesting when I get that far. The drains are working absolutely fine, and the gutters are working absolutely fine. I've not seen them overflow, even though we've had some horrific rain here recently. That leads me to the doors. Now the doors have definitely shown signs of distress. You can see there's a piece chipped out there, there's a piece chipped out on the top. Yeah, they're not brilliant. And it wasn't until, here you go, I'll just show you around. It wasn't until I had put them up that I knew there was going to be a gap underneath, so I left a purposeful gap. That is a piece at the bottom here. This is a piece of oak, and it's been treated. However, this door is absolutely fine, and I'll just show you the hinges are the same distance from the edge of the board, edge of the hole I should say, but this side, I don't know what I was thinking. That's okay. That one, much closer. So that means that this door now collides with the paving slab there. My bad entirely. I don't know what I was thinking, but yeah, what can I say? Buggered it up. I don't know if this comes over particularly well on camera, but you can probably see the surface is bulging a little bit in places. This ply was cheap, and that's I think my biggest regret building this workshop was actually not spending some decent money on the doors. I shut the doors, and both of these doors have actually settled. So I don't know if you can see that particularly well, but the gap there is probably 3mm, and down at the bottom of the door is enough for you to get your pinky in. So that does need to be sorted as well, and that would, I need to put a block, I think, in the top here to fix that. Inside, things continue to get better. As you may have seen, I've brought my old edit computer down here. That has now been installed. That absolutely is spot on. It's an old Z800. It's I think I've had it 15 years, and it's been a cracking computer over the years, but it's had to be replaced with something a bit more modern. I've added some LEDs into my cupboards, so you can see what you're looking at now. Quite chuffed with that. And moving around, this is all looking really quite swishy. I'm getting there. I really am getting there. However, there we go. I broke this this box, the connection box for this dust extractor when I moved it down here, and I opened it the other day thinking I'll just make a plate and fix it, and I found this capacitor. I don't remember when I was at college learning about electronics that capacitors ever looked like that. So I need to order another one. So hopefully that's answered a few of the questions that I've had over the last year and a half about this workshop. Yeah, it's big. What would I have changed if I did it again? I think I might be tempted to make it a bit smaller and do it within the 30 square meters. However, having done it, yeah, it was definitely worth the hassle. For instance, it took me a month to do the calculations, to do the research and the calculations. I will put in the doobly-doo links to where my spreadsheets came from, and it's the cheapest solution that I could find to give you the relevant calculations. So if you've made it this far, thank you very much. There's a lot of information in this video, and hopefully it will help somebody out who's contemplating building their own shed, garage, summer house, garden office, etc. If I was doing it again, I think I might be tempted to make the workshop smaller to fit within the 30 square meters. However, that would mean basically chopping off about a quarter of what I've got here. So I'm not really sure that that would have been the right solution, but it certainly would have saved me a lot of money. The overall construction cost for this was, I can't tell you exactly, but it's certainly north of £20,000. So how far north, I can't tell you exactly, because I did keep I did keep a log and a spreadsheet of all my costs, but in the end I thought, nah, this isn't helping me. It just made me lay awake at night thinking how much I spent on a blasted workshop. So yeah, anyway, thanks very much for watching. Do hit the like and subscribe button, and please share this video with somebody who's thinking of building their own space. Is it worth it? Damn right it's worth it. Is it a lot of hassle? Yes, it is. Physically it's knackering, mentally it's exhausting, but at the end of it you forget all that and you just enjoy your new space. So thank you very much, and we'll see you on the next one when hopefully I've got over my COVID and we can actually build something again. Take care, we'll see you next time. Oh. So if you made it this far, thank you very much, and please hit the like and subscribe, and share the video, because it helps the channel grow. And hopefully, if somebody gains something from going through the kind of construction drawings and calculations that you need in order to get through building control and planning, then that would be quite worth it for somebody, I think. So please feel free to share the video if somebody's in the process of building a shed, workshop, garage, or thinking about it. This might help. So thanks again, and we'll see you on the very next one. Take care.